All right, guys, so 3.6 is the chain rule, and can you add this in? Parametric equations, okay? So actually the first part of our notes is just going to be the chain rule, and it's, I say like the easy kind of chain rule, but we've already kind of done this before. So the chain rule is basically the power rule, okay? And the chain rule is like if you have to do a derivative, and then that derivative has another box in it. So it's like a box in a box. That would be the chain rule, right? It's like a chain effect. Okay. So if you have f of g and you take the derivative of f of g, you would have f prime of g times g prime, right? So you take f prime, you leave the box alone, and then times the derivative of the box. The box was this part, so g prime. And then you take the derivative of, you know, the little x here, and then you get times 1, right? So that would be the chain rule. So this box has its own box inside, and that's why we say, oh, this is the chain rule. Okay? So an easy version of the chain rule, I'm going to say, is something like this. And I feel like you guys can do that, you know, by hand. And if you did it by hand, you would be like, oh, I bring the 3 forward and then blah, blah, blah. So go ahead and write that out right next to it. And then, you know, it looks familiar, right? So 3 comes forward, blah, 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 to the second power times the derivative of the inside, which is 6x. So you guys are good at that. But I want to show you where the chain rule really comes from. This is what we actually did. So what we did is we said, okay, let's set f of x equal to something cubed. And then the inside of that, instead of calling x, we're going to call it g of x. The inside of that is all the stuff that's stuff inside, right? So really what we did here, and we didn't even realize it, is we used the chain rule, because look what happens. F prime is going to be 3 comes forward and then to the power of 2. And then g prime is going to be the derivative of the inside, which is the derivative of this, which is 6x. So see how that's exactly what we did. We did f prime, that's f prime, right? This quantity prime. And then the derivative of this quantity is right here. So here's f prime and then here's g prime. So really, we've been doing the chain rule. So I wanted to show you, you know, that we've been doing it, basically. So these are your only examples for chain rule. And then here's another one. So what's the derivative of tangent? You're actually supposed to know that by now. The derivative of tangent is secant squared. So then we have secant squared quantity times the derivative of that quantity. Okay, so let's see how that would work out. What would be f of x there? It would be the tangent of something. What would be g of x? It would be the inside of it. So look what we actually did. We have f prime, which is secant squared, right? Just f prime. And then times g prime, which is the derivative of this. Well, what's the derivative of this? 0 minus the derivative of sine is cosine. So negative cosine, because this is a minus sign. And then cosine of a quantity times the derivative of that quantity, which is 2, right? So the derivative of 2x is 2. So there's your, you know, examples of chain rule. Okay, so now we're going to get into parametric equations. You need a highlighter, a different color highlighter. So like, I like to highlight in one color, and then I want you to use a different color highlighter for this one, okay? So parametric equations, here's like the main gist of it. Parametric equations are going to have more, than one variable. So they're going to have one or more independent variables called parameters. Do you need to know that word? Not really, but when I say parametric equations, like hopefully you'll remember what I'm talking about, okay? So let's say you have these 2 pieces of information. So see how there's like an x, a t, and then there's a y. How annoying, right? So because there's an independent variable of t, but then really there's this like x equals something in terms of t, y equals something in terms of t. All right, we got parametric equations going on, okay? We have parameters, all right? So what we're going to do is we're going to number these equations, all right? So this is equation number 1, and you know, dx in terms of t. So we're going to find the derivative of x in terms of t now. We're going to find the derivative of y in terms of t. Okay, so we want to find dy over dx. You see how this is in terms of t, this is in terms of t, we're going to find this. So what we're going to do is we're going to first find, again, the derivative of x in terms of t. So the derivative of x in terms of t, what is the derivative of secant? You're supposed to know that by now. It is secant tangent. All right, so we got that part, okay? What is the derivative? And then I write it in this way. So for parametric equations, you really want to write it as a dx over dt, derivative of x in terms of t, right? Because your independent variable is t. And then what's the derivative of tangent? Well, it's secant squared. So dy over dt is secant squared t. Okay, so now we have our two derivatives. I numbered them, so I can really see this one comes from here, and this one comes from here, right? So these two together, these two together. All right, so now just kind of think about it. If we have dx over dt, and we have dy over dt, how can we get dy over dx? How can we somehow, I mean mathematically here, not just throw away, but mathematically, how can we get rid of the dt's? Well, maybe we can we see here? Maybe we can divide away the dt's, right? Wouldn't that work? If we divide this by this, and we have the same denominators, what happens when you divide fractions? Think of this is a fraction, right? So when you divide a fraction, I'm going to turn off my phone, sorry. When you divide a fraction, you actually multiply by the reciprocal. When you multiply by the reciprocal, you get dt over dx, and the dt's divide away. So really, you get, I'm just writing one over the other, so dy over dt is this part, dx over dt is that part. So that is going to be dy over dx. All right, I'm going to simplify a little bit, right? There's a secant squared over a secant, and then you get a secant over tangent, right? So I just wrote secant squared twice. So then I get secant over tangent. Okay, so this is not my final answer, okay? So right now we're in terms of t, but we want to maybe not be in terms of t. So how about this? Isn't secant t x, and isn't tangent t y? So our answer in terms of x and y is x over y, right? Because this is, right, it's the same thing. So we're just substituting. So we have two answers. We have this answer, which is in terms of x and y, and then we have this answer, which is in terms of t, but this one isn't actually simplified. So if I kept going, what is secant 1 over cosine? What is tangent? Sine over cosine, and then what's 1 divided by cosine divided by sine divided by cosine? Oh yeah, the cosines divide away, it's 1 over sine. Well, what is 1 over sine? It's cosecant t. So we have an answer in terms of x and y, and we have another answer in terms of t. And that's what we're going to look for. We're going to look for answers in terms of x and y, and if possible, we're going to find both. Okay, so that's our goal. We want to find both, an answer in terms of x and y and another one in terms of t. Sometimes it's not possible. I'll tell you when it's not possible. But for now, that's what we're going to try and find. Okay, so example 2. So given, right here, given y equals e to the t power, x equals ln to the t power. Okay, I'm going to number them, and then if you try to do exactly what we did right now, you'd have a little bit of trouble. You can try it, okay? But I'm going to give you a hint. Sometimes you got to mess with it a little bit. So for this one, I'm going to call it x equals log base e of t. So that's true, right? Log base e, ln, is the same as log base e. Okay, so now I'm going to first find my derivatives. So number 1 and number 2. The derivative of e of t is just e of t. The derivative of ln of t is 1 over t. And this is just for later, okay? We'll see why we need it. But if you don't have it for now, you're like, oh, I don't need it yet. So, you know, we'll just wait till later. All right, so there's number 1 and 2 derivative. And then, how do we find dy over dx? Oh, we're going to divide this one by this one, right? So let's go ahead and do that. And then when we do that, we put 1 over the other one. We're like, well, that doesn't really help me. Okay, so here's, well, I get this. So this in terms of t is fine, right? So like divide by a fraction, you multiply the reciprocal. So in terms of t, that's my answer. Okay, that's why I have a little t here. So So in terms of t, that's my answer. But what about in terms of x and y? Okay, let's change it around a little bit. So maybe with that t, I can be like, okay, using this right here, I know x equals log base e of t. Well, if x equals that, then I should be able to change this to an exponent. How do we do that? E, that's the base, to the power of x equals t, right? We're just changing from a log to an exponential. So e to the power of x equals t. All right, so now I'm changing that t into an e to the power of x. So it's y over, see, because y is e to the t, so I can change that into a y. And then t is this, so I replaced it, and then now I have my answer in x and y. So I have an answer in terms of t, and I have another answer in terms of x and y. They'll ask you for like probably one of these, but you have to be able to find both, right? This one's a little easier to find, and then sometimes you got to play with it a little bit to get this, all right? Okay, number 3, let's try again. So find dx, or dy over dx given these two. And these two are a little different, okay? See, this one, like this one was in terms of t. This one was in terms of t. This is in terms of t. This is t in terms of x. So you be careful, okay? So, I'm going to find my derivatives. So find my derivatives. That shouldn't be a problem. So derivative, I'm going to write it nicely. dy in terms of t is 2t plus 3. Take the derivative. And then in terms of x, right? So dt in terms of x, derivative of t in terms of x, because that's my independent, right? That's in terms of x equals, take the derivative, you get 5. Okay. Well, how do I get dy over dx? How do I make this dy over dx? Can I divide? No. You multiply. If you multiply these two fractions, look at these two fractions. What happens to dt? They divide away. And you get dy over dx. So I multiply, and I get this. That's all I did. I multiplied. And then I get this as my answer in terms of t. Right? So that's my answer in terms of t. Okay. And then how can I change it to in terms of x and y? So let's see. Let's go ahead and think about, how else can I write this? Isn't this the same as if I, oh, sorry. I need to think about it for a second. 10 times, what did I write 10 times? 5x minus 2. Oh, I did that. Do you see what I did? So 10 times t, which is 5x minus 2, plus 15. So here's the same thing, except the t got substituted in. You see that? Sometimes I gotta think about it anyway, right? So I'm the one who did the problem, but you know, take some thought. And then I multiply it out, I add together, and then now my answer is in terms of x. Well, x and y, but in terms of x. Okay, so I have an answer in terms of t, which is easier to find, and then I have an answer in terms of x and y. Okay, all right. I think this might be the last one. I don't remember. Maybe not. So I have these two functions. I want to find dy over dx. Okay, so you find the derivatives of the two functions. That's not too crazy. And then you what? Divide, right? Because dt is on the denominator for both. So I go ahead and do some division. I write them over each other because it's this one divided by that one. And then I get a negative tangent t. That's my answer in terms of t. Is there anything I can do? I think so, because see that sine t is equal to x and cosine t is equal to y. Okay, let's go ahead and replace. So really it's negative x over y as well. So that's another. So that one was kind of quick, efficient, to the point, right? That one was kind of easy. Okay. So the last one, let's give it a try. I remember the last one was a little bit different looking. Okay. And I can tell why it's different looking. Again, it's going to be a little bit trickier to get my second answer because this is y in terms of t. This is t in terms of x. Okay. So the first part's not bad. Finding the derivative, finding this derivative is not going to be bad either. So the first part, I take my derivatives. So the derivative of e to the t is e to the t. The derivative of cosine squared, be careful, remember, this is a quantity squared, is going to be 2, and then cosine to the first power, and then the derivative of cosine is negative sine. Okay, so I have this as my second derivative. How can I do, oh, sorry, I wrote dx right here. I'm going to change that because I made a mistake, because this is dy in terms of dt. So in terms of t. So I'm going to put a t here. Okay, so dy over dt, this is dt over dx because this one is in terms of x. And then, remember? So I can rewrite this, and this should look very familiar. This is a double angle formula, and that gives me a negative sine of 2x. My negative sine of 2x, okay? Now I can go ahead and multiply these to get dy over dx, and then I multiply. So here's this times this. So all I did is multiply. That is not an answer in terms of t, huh? So this one, I cannot make it in terms of t. I know, it's crazy. There's no way for me to make it in terms of t. That's why there's a little question mark, okay? But I can make it in terms of x and y for this one. That is possible. So here's how that's possible. This is t. This is t. Let's just plug it in. So we plug it in, and now we have an answer in terms of x and y. There's no way to make this in terms of t because we're not going to take the inverse of a cosine. Well, it'd be cosine inverse, but it'd be like nice and weird and complicated, and we don't know what the cosine inverse of that would be. But for the other problem, the reason that we can take t and then set it equal to something is because a log is the inverse of an exponential, and we can rewrite a log as an exponential. We cannot write a cosine in terms of, you know, something else. So unless we do a cosine inverse or whatever, but that's getting a little too ahead of ourselves, okay? So final answers for number 5. Okay, so this is what you're going to do. So actually all of these examples were parametric equations. That's going to be part of your homework, okay, parametric equations. But the ones that I also really, really like are these chain rules. And the chain rule, I'm going to give you some examples on the back. So on the back, I'm going to say, OMG, seriously, these are awesome problems. This is a homework problem. This, I gave you the answer for, even though it's not a homework. See, 56 is not a homework problem, but it's so good. So not homework, but it's just so good. You should try it. If you get 57 completely correct, then great job. Maybe you don't have to try it, okay? Because you're all good. You got all of 57 correct when you checked your answers. But if you got any of them wrong and you had to go back and check your work or ask on the homework helpline, you should for sure do number 56, and here are your answers. And just to kind of get you started, here's a twinsies problem. I made a twinsies problem for you, okay? So I gave you a table with f and g and the derivatives when you plug in 1 and 2. Okay, so for number 1, this one's pretty basic. So take the derivative, that would be just 2 times f prime, and then I plug in 1 plus g prime, I plug in 1. Okay, I look up here, I look for f prime of 1, g prime of 1, I plug them in, I get a final answer, okay? I'll do like one more with you, how about that? So what about f times g? So if it's f times g, those two things multiplied together, how do you get the derivative? F times g prime plus g times f prime, and then you would get f of 2 times g prime of 2, plus g of 2 times f prime of 2. And then I look up there, my f of 2 is 1. You have to be so careful. And then my g prime of 2 is 4, plus my g of 2 is 2, times my f prime of 2 is 3. That would equal 4 plus 6, which is 10. I'm hoping the answer is 10. I wrote the answers all on the, yes, it's a 10. So the first answer all the way to the last answer. Okay, I'm going to do the very last one with you just to kind of remind you. This one is the trickiest one, okay? So you should try the other ones. You know why? I'm just giving you extra problems to try. That's all. I really like this one that starred, and I really like this one that starred. So you should try this on your own, okay? Use a pencil. All right, this is a power rule. So power rule comes forward, and then what do you have? So this is the original. And then using the power rule, I'm going to say comes forward to the negative 1/2 power times the derivative of the inside. What is the derivative of the inside? It's going to be 2f to the first power times f prime, right? Plus the derivative of g is just g prime. So this is your derivative of the whole thing. I don't like to write of x all the time because I'm lazy, and I write it at the end. Okay, and then what I do is I slowly, this is exactly the same thing, I swear, but now I wrote of 1, right? So g of 1, f of 1, f prime of 1, g prime of 1. So I very carefully write in my of 1s, and then I plug in right there, and then I get my final answer. So my final answer is 15 over 2 root 13, okay? So all the answers are written on your paper. I already fixed that so that it says 12 on your paper. So this is, again, a twinsies question. So if you get these correct, if you get G correct, I'm going to say that. If you get, like, let's say these correct and you get 57 correct, don't worry about 56. But if you get any of these wrong and then you get like something from 57 wrong, then you should really try 56 just in case. You should ask for my help. You should, call your friends, whatever. Okay? So there is our last section before our quest. And then we have 3 more sections of chapter 3. I know, it's extra long. Okay, good luck, guys.